Okay, we are live. Let's double check that everything is correct technically. Welcome to the second part of this live stream series that we're doing. Just going to make sure everything is okay here. Let's see. And we should be good. Okay. Going to start this with a poll, which you can join via Slido. And this poll will be using this as a way to verify that we've got everything working correctly and that you can follow along. So once you're ready, I'm going to activate the poll. And this will help me guide our way through this and figure out where we're all at in this second part. So I invite you to scan the QR code or go to slido.com and enter the code that we have there. That's 333999. And so far, are we getting anything? Okay, so far no one's answered yet. Let's see. Okay, first comment, yes. Okay, everything is good. All right, so one person has said is not watched. Okay, so I'll give a brief overview of what we covered in the first one. Let's see. How about REST concepts? And whether the code is legible. All right. All right, so a little bit of background on this series in case you are not familiar. Let's see. Okay, so the goal of this series is, as we sort of covered in the first stream, was to demonstrate different patterns, problems, and architectures for a modern architecture. And what we're going to do is we're going to build on the content from the first stream. So in the first stream, we built a grading system for online courses. And we focused on building the data model for this. We did this with Prisma Migrate, and I can show a bit the Prisma schema here. This was the Prisma schema that we used, and we had a bunch of concepts. We had users, we had courses, and then users could be members of a course through this course enrollment. And this course enrollment was this explicit, what we call an explicit many-to-many relation. We use this in order to be able to associate multiple users with multiple courses. So a single user could be a member of different courses, and courses can have multiple users. In fact, they can have the same user in multiple courses. Then we had tests, which are also associated with a course. So every single course can have multiple tests. And each one of these tests has a test result, which is associated with the student who sat the test and the teacher who graded that test. And just a quick reminder that both students and teachers, they're both users, and their role is defined through this course enrollment relation table. So this course enrollment relation table has this role field here, and that role defines whether the user is associated as a student or as a teacher. So, can I increase the font size? Oh, thank you for the comment, Nicholas. I'll increase the font size. I also urge you to go and update your streaming quality to full HD. In the previous streams, we had some users point out that the resolution wasn't high enough, so we worked to get this full HD working. Great. So besides building this schema, what we did in the previous stream, we ran a migration using Prisma Migrate. And the result of that was a working database. So I'm going to just increase the font size here too, so you can see this. And I'm going to open up PGCLI to connect to the database. And here we're able to see all of these different tables that we saw in the Prisma schema. I'll put the Prisma schema here on the side so you can see both. And each one of these models maps to a table. So we have a user table, a course enrollment, and we can actually get more information about each one of these tables using this \d and then the name of the table. This is the PostgreSQL that we're using. So we created the schema. We created the database schema using the Prisma schema and Prisma migrate. And then lastly, at the end of the previous stream, what we did is we created this seed script. So this was just one big TypeScript function, which had a lot of different Prisma Client calls. And each one of these calls was responsible for populating the database with different data. So for those of you who are just joining now, welcome. What we did is we created here users, we created a course, we attached members to that course, and we sort of looked at the ergonomics and the way that the Prisma Client API works. What we're going to do in this part of the series is we're going to actually look at three things. We are going to look at the first thing that we're going to do is we're going to create an HTTP server, and this HTTP server will extend it and we'll add routes to it so that it actually becomes a REST API. And some of you, I'm sure, are wondering, why are we using REST? Why are we not using GraphQL? So just to address this up front, we've worked a lot on many examples at Prisma with GraphQL, and we still believe that REST has its use cases. And so this stream will focus on how to build a REST API and show some of the different use cases for Prisma. Because Prisma is so flexible as a sort of database access layer, it can be applied to REST, it can be applied to GraphQL, and in this one we're going to focus on REST. So REST APIs are essentially a way to expose a set of resources over HTTP. And those resources, as we'll see, they correlate to these models or these these tables that we create in the database. So for example, in our schema, we had a user model, which corresponds to the user table. And we're very likely going to have an endpoint, which will get users, create users, update users, and delete users. And so in this stream, what we're going to do is we're going to actually build all of that. And we're going to address two aspects of building a REST API, namely validation and testing. Validation is extremely important in all applications or all APIs. And the reason for that is when you are exposing an API, essentially you're exposing publicly an endpoint or a set of endpoints which allow users and API consumers to interact with the API. And so the challenge there is that you never really know what kind of data will be submitted to your API because it's publicly exposed. And one aspect of that is adding authentication and ensuring that you know who's doing what. But even when you authenticate a user, you still need to verify that the input, the payload that is providing while interacting with the API matches what you expect. And as you handle the data, you really want to make sure that it adheres to a certain structure. So as I said, today we'll talk about the REST API, validation, and then the third thing that we'll look at is testing. What we're going to do is we're going to use Hapi.js, which is a popular Node.js framework, and we're going to use that, of course, with TypeScript, and we'll get more into that soon. So we're going to use Hapi together with another framework called Jest. In case you're not familiar, I'll just load it up here. So Hapi.js, this is where you can find more information about Hapi. And Jest is a testing framework, which is really nice. It's fast, and it it just makes it so much easier to do testing. So we're going to combine the two, Hapi and Jest, and we're going to use this functionality that Hapi has in order to test the API by simulating HTTP requests going into the API. So a little bit about the prerequisites for this part of the series. You should have some basic knowledge of TypeScript, Node.js, and relational databases. In case you're experienced with JavaScript, I don't think you need to worry too much, especially if you haven't had a chance to try TypeScript. You'll still be able to follow along, and I'll sort of flag some of the concepts as we go along. As I mentioned before, we're going to be using Postgres as the database. And in case you want to look at the code base, you can find that on GitHub. And the address to find that is tocolor/real-world-grading-app. I'll also share this in the comments. And to sort of follow along from this part, you can look at the branch named part 2. So I'll just share the link so you can have a look at the code if you feel like. All of the completed part, by the end of this stream, we should be at the point where master is. So the part 2 branch specifically has a lot of what we're going to cover omitted so that we can actually do that live. So that was that. And then before we dive in, I'm going to make sure, so I have Postgres running, so that's all good. And now let's talk a bit about REST. So in case you're not so familiar with some of the concepts of REST, let's sort of cover the base ground here and start with what REST is. So REST isn't actually an official standard. It's rather just a set of conventions that developers follow to expose state-related operations over HTTP requests. This is one of the more standard ways to expose data or to build APIs. And if you're curious about some of these conventions, there's a lot of resources on the internet. I also highly recommend the GitHub documentation. They also have a REST API, and you can look at a lot of the different concepts and the different approaches that they use in order to expose this API. And so an API has this really important concept called endpoints. An endpoint is essentially just an HTTP URL that you can access, and it has a path, it has an HTTP method. The HTTP standard has different kinds of request types. It has GET, it has POST, it has DELETE, it has PUT, it has a bunch more. And what these HTTP methods, they're useful because they allow us to determine the type of operation that this endpoint exposes. So for example, what we're going to do is we're going to create so imagine that the API is called myapi.com, and then we're going to have an endpoint that might be called /users, and it will be a get endpoint, and that will be a get users endpoint. And similarly, we might have a delete where we have here a user ID. And this is not a string, this is rather a parameter, which will delete a single user. And in addition to that, we'll have also a post so that you can actually create users. So that will be used to create a user. And lastly, we might have a put. And the put would obviously need also a user ID because that will be used in order to update an existing user. So this is our plan for today. We want to implement these 4 endpoints. This doesn't cover, of course, the full schema, as that's beyond the scope of this stream. But in the coming days, the repository will be updated with the implementation code for all of these endpoints beyond just these four. But these four should be a good illustration of the different kind of patterns that you would have for most of your resources. Throughout this stream, I'll probably be using two words interchangeably, root and endpoint, but I'm really just referring to the same thing. Endpoint is the term that is often used in the context of APIs and REST APIs, and root is the term that is used often in the case of like HTTP servers. So when you're actually building the code, you're usually defining these roots. So let's get into it and look at some of the dependencies that we need in order to build this. So the first thing is I'm going to open up here the package JSON. And in this package JSON, you're going to already see some of these dependencies here. We have Hapi Boom. Hapi Boom is, so a little bit about Hapi.js. Hapi.js is a Node.js framework for building HTTP servers, and it supports validation and testing out of the box. The core functionality of Hapi is provided through this Hapi package, and a lot of the other functionality will be through other modules. For example, this Hapi Joy is a validation library. I'll open up the page for Joy, because Joy is a really, it's a really nice way to validate objects. Let's see, just so you have an example here. So, not sure if this is actually the best. Let's see. So there we go. So similar to how we define these schema, these Prisma schemas, with Joy, we define these JavaScript objects, essentially, which allow us to validate input data. And this can be used independently of Hapi. Of course, it integrates really well with Hapi, as we'll see very soon. And so let's start by, I'll open up this package JSON again. So we spoke a bit about Hapi, about Joy, and then we have Boom. Boom is just a simple library for HTTP errors. So as I mentioned before, HTTP has different HTTP methods like get, post, and delete. And it also has these status codes. And Mozilla has a really nice page on response status codes. And essentially, when you make a request, for example, when I just loaded this page, a request was made to the Mozilla servers. And each one of these requests that was made has this status code. And the status code indicates how the request went. So generally, successful responses range from 200 to 299. Redirects are in the 300 range. Client errors are in the 400 range. And server errors are in the 500 range. I'm going to go back to the comments to see if there's any question. Okay, so we already have a question. Is there a way to avoid overriding the field mapping added manually in Schema Prisma when running Prisma Introspect? So thank you for that question. Yes, there is a way. This is being worked on as part of this feature called reintrospection. We won't be covering that because we're not using the introspection flow, which Prisma supports in this stream, but I will share a link later so that you can find that. So thank you for the question, Ayush. And now back to the code. So these were the dependencies that we had. We also had Prisma Client, which we already added, and we have here date functions. Date functions is just a simple date utility, which we used in the seed script, if you remember. We just used it to do some basic arithmetic with days. And then on the dev dependencies, what's really important here, since we're using TypeScript. So generally when working with TypeScript, one of the challenges is that some libraries are written in JavaScript and they don't have the types defined. And so there's a lot of community effort to define these types so that you can use these these libraries written in JavaScript in a TypeScript project. And so this is why I added here this types dependencies for Hapi and for Joy, also for Jest. And it would probably be a good idea to also add the types for Node. So I'm just going to do that very quickly. The -d here is to mark it, to install it and save it as a dev dependency. And we should see it show up here shortly. Okay, so we have that for Node 14, and I think that's the version of Node I'm running. Great, and we also have Jest, which we'll be using for testing. And we have a bunch of scripts here. Now let's start with the server. So now we get really into it. A Hapi.js server, really, it's not that much different than, say, Express or other servers you might be familiar with. Essentially, you instantiate a server and you bind it to a port and to a host. Here we pull those from environment variables and we default it to localhost and 3000 if that's not defined. Once we deploy this to production, we might actually set these environment variables to have control over that. And a little bit about environment variables. So environment variables are part of this 12-factor app. If you're not familiar with a 12-factor app, that was a set of conventions for building applications. And you can look at that here. So 12factor.net. Yeah, so this is generally good practice for a lot of runtime configuration to be stored in the environment variables. So that's where this principle comes from. And here we define a start function. And because we're using TypeScript, I'm also defining the types here. So for example, for this Hapi server here, I've defined this Hapi server. And this type is in fact defined inside this Hapi, this types Hapi package that we added. Here, the start function also returns the Hapi server, and simply all we're doing here is we're just calling start, and we're logging, hey, we're running this server, and here I'm actually calling the start function. So if I go to the terminal and I run this, and I can do this with npm run dev, this is a script that I've defined. And because this is written in TypeScript and we're in development mode, so typically with TypeScript, you would run the TypeScript compiler and then the TypeScript compiler would generate the JavaScript for you and then you would run the JavaScript. But obviously while we're developing, this can be quite cumbersome. And so we're using this ts node dev, which we're passing it the respawn parameter here. And that will ensure, I'm sorry about that. That will ensure that the server is restarted automatically once we make changes. And of course, it'll automatically transpile. So if I just command save here, you should see, oh, it's restarting it. And that's the behavior that we're expecting it. So we've defined this server, but it doesn't have any routes defined. So that means if I try to make an HTTP request to it, it'll just tell us, hey, not found because there isn't a route defined. So let's start by defining a route. And so generally speaking, we define routes before we start the server, and we do that using this server route. And as you can see, we're already getting this really nice and rich auto completion. This is really useful, and it's all because we're using TypeScript and the Hapi types. It sort of like provides us with really handy auto completion here. So the first thing that we're going to do is we're going to define the type of method. And what I'm going to do here is I'm going to define a status endpoint. Generally in backends that are, and we're already getting some errors here. We're also getting these errors here. But generally when I'm building backends, it's really it's nice to have a status endpoint just to know that the server is running correctly, especially if you're working with a database. You want to just have a simple status endpoint that doesn't even access the database so that you can make sure that it's running. And so this is what we're going to do here. We're going to define its path as just the root path, and we're going to have to provide a handler here. And the handler is the function that will get called every time a request comes in. And the signature of a handler is you usually have the request, and we can actually see that with the auto completion here. So okay, and of course it can be async, and so we have here this request, and the request type, I believe it's happy.request, and the and then we have also this what's it called, the response toolkit. So usually it's just referred to as h, and then happy.toolkit, there we go, response toolkit. And if I hover over this, this is essentially the way the setup, it's a collection of properties and utilities that basically that will allow us to send a response to the user. And so here all I'm going to do is I'm going to do h.response, and here I can pass it an object, and that will be actually the response, and I'll just give it up true and set the code to 200. Now our server is running, and if I make another call, what I should get is I should get it 200 instead of the 404 that we saw before. And additionally, I should see this up object. So that's wonderful. That worked all great. We also have the content type, which is set by Hapi because it sees that this is a JSON object. And so we have this status endpoint. But, you know, if we're going to be defining all of these endpoints that I've described before, I'm going to actually try to get that again. So I'll open that up here in just a simple markdown. And then we also had this delete endpoint. So we're going to have a lot of endpoints, and if we start adding all of these endpoints to the start function, it'll start looking really, really messy. And luckily, Hapi has a really nice abstraction, and has a really nice solution for this, and it's called plugins. So what are plugins? Plugins are the main mechanism of breaking up the backend into isolated pieces of business logic. So they're essentially just a lean way to keep your code modular. And what we're going to do is we're going to actually take this status endpoint and move it into a plugin. So for that, what I'm going to do is I'm going to first create a plugin. Oh, it looks like I already have it here. I'll delete that so that we can recreate it. And let's look at how this plugin will look. So we are going to first import Hapi here. And then we're going to just define a constant here. It's going to be just an object, and I can already assign it a type. So it's a plugin. And you can pass using generics different options to this plugin, but we don't need any, so I'm just going to pass undefined here. And then it's just an object, and these plugins, they have a bunch of very simple properties. It has name and register, really. These are the main ones that we care about. And so here we pass it a name. The name is actually optional, but as we'll see, it's useful to have these names. And then it has this register. So the register function is where the magic happens. Essentially, it's a function that will automatically get called by Hapi when we register this plugin. And it passes it this server object. And this server object is the same one that we're using here, that we instantiated here. So we don't need to do any dependency injection, any imports. We get it passed, as we'll see. And that's Hapi server. And here we have this async function. We can do whatever we like. And what we want to do is we want to define the root. So I'm just going to go back to server and I'm going to cut this. And I'm going to paste that here. So that's all great, but nowhere do we tell so far Hapi that we want to register this. So in order to register, we need to import to register the plugin. We need to import it. So I'll import status plugin from plugins/status, and I think it can just be camel cased. And then here we are going to add a function call called register. And register is the function that we use in order to register these plugins. And you can pass it simply a single plugin, or you can pass it an array. I'm going to use an array because we're going to add more plugins later. So that's all nice. Let's see how we're doing here. Let's try to run this. Oh, okay. It has no default export. So indeed, I didn't export anything. And so I will add this export here. And let's see if that works. Oh, and the server is running. So now, if I go back here and I try to make a request to it, great, so we got the response. And that means that we've now successfully defined a plugin and we've modularized the status functionality into its own plugin. Now I'm going to pause here and look if there's any questions or comments. Okay, I see that we need to increase the font size. Also, welcome to Exception 360. Thank you for joining. Sorry about the font size. I'll try to keep that big. And I think we are ready now to continue. Great. So we've defined this one plugin. And throughout our application, we're going to want to use Prisma. So far, there's nothing here that makes use of Prisma. And because we are going to define these different endpoints are going to make database calls the same way that we did here. They're going to use this Prisma, this instantiated Prisma client. And so for that, we're going to create a plugin for Prisma. And this plugin will essentially allow us to access Prisma from all of our other plugins. So let's take a look at how we can do that. Okay, we have this already defined. I'm just going to delete this. And I'm going to just make it one tab here. So we have this, and we can copy this import line. And then we can define here the plugin. So we are going to call this the Prisma plugin, but the name doesn't really matter here. So const Prisma plugin is of type happy.plugin. Undefined, there's no special properties, and it's equal to that. And then here we first give it a name. So I'm just going to call this Prisma. And again, we have this register function. And here we pass it the server parameter, which is of happy type sub. And what we're going to do here is similar to how we did in the seed script, is we're going to instantiate Prisma client. So created this Prisma instance, and now that's only accessible here within this scope, but we want to make that accessible to the rest of the application. And so for that, we can use a feature that Hapi has, called the server app object. So this is a place to store server-specific runtime application data without potential conflicts with the framework internals. So this is almost like a global object that is accessible wherever server is accessible. And as we'll see, server is accessible within all the root handlers like status. So here we define the root, and we can actually access this server app through the request object. So we are going to assign it here. So server.app.prisma is Prisma. As simple as that. And then, not sure if you remember, but one of the things that's important when using Prisma with Node.js is to ensure that when the server is stopped, that the connection, that we disconnect from the database. And for that, Prisma has this disconnect function. So Prisma.disconnect, I believe it is. Yep. Let's see. Oh, we didn't import Prisma Client. That's why we're not getting the types. So I'm going to import Prisma here. So import Prisma Client from Prisma Client. That's great. If I hover over this, I see I have the type for it. And essentially, that's what the disconnect call would look like. But we don't want to just disconnect here. We want to add what we call an extension function in Hapi's terms in order to make sure that this happens only once the server is stopped. So I'll open up just the Hapi reference here just so you have an idea of what this is all about. Extensions, or I believe it might be just ext. Let's see. There we go. So an extension function is really just like a hook function. It gets called when a certain event happens. And what we want to do is we want to add a hook to the on post stop, which will be called after the connection listeners are stopped. So this is what this will look like. So I can go server.ext and then open up an object here and then pass it a type. And then we wanted it to be on post stop. We even have all of these references here, again, thanks to TypeScript and the types. And we're going to pass it a method. This can be an async method, which has the server passed into it. And what we're going to do here is we're going to call server.app.prisma.disconnect. So that was that, but we're seeing these squiggly lines. And we're seeing these squiggly lines because VS Code has really nice TypeScript integration built in, which means that it'll actually run the compiler in the background. If you're not using VS Code or you're not getting these squiggly lines, there's also a script which you can call inside the repo. And that is called npm run compile. And really all it does is it just runs the TypeScript compiler. And if we run this, we should see some kind of an error here. So what we have is indeed we're getting this error, and it's saying the property Prisma does not exist on type server application state. Yeah, that's the one. So how can we resolve this? We can do this using this technique called module augmentation. And apparently this is the standard way to handle these kind of things, where you're essentially extending a type that is already predefined. And we do that with the following block. So here what we do is we sort of declare this module, which is the Hapi module. And we add to the server application state interface this Prisma, and we assign it a type. And if I run the compile again, it should pass. Hopefully. Oh, and there we go. Okay, good. So we're almost done here. The only thing that we have left is to register this plugin. So we can do that from the server TypeScript. And what we're going to do is we're just going to copy this line and we're going to call it the Prisma plugin, and we're going to import that from Prisma. And then we're going to pass it here. And why are we getting? Oh, I forgot the default export again. So export default Prisma plugin. And let's see if that's a paste. And indeed it is. Okay, I'm going to pause here and I'm going to see if there's any questions or comments. Oh, can't see, increase the font. Really sorry about this. Is this the font of the editor that you can't see, or is it the font of the terminal? I'll try to make it as big as I can. Let's see. Really sorry about this. Hopefully it should be big enough. In case you're having trouble, I would also suggest try to make sure that you're running 1080p on YouTube. Okay. Now we're ready to continue. So we've defined this status plugin and this Prisma plugin. And now we're going to start to define the endpoints for... Oh, okay, that's a good question, right? Yeah, good time also for the question. So we had a question from Hoodwatcher. Is there a reason you use Hapi instead of Express? For example, just a personal preference, or because it's better in combination with Prisma? Well, Hapi.js provides built-in testing functionality and validation out of the box, and it follows a really declarative approach. It also has this sort of plugin architecture, which is really useful. So there's nothing wrong with Express. Of course, you can do all of this with Express. Both of them would work really well with Prisma. But just because of these features, which are really important, validation, testing, and modularity, they're sort of solved for you. So you don't really need to think about that. But Express.js is also great. And most of what we're doing here applies to all servers, all Node.js servers that you would use. I mean, in principle, it's all the same. So thank you for that question. And now let's start by defining some of the user endpoints. I think I already have this users plugin here, which I'm going to delete just so we can build it from scratch. And I'm going to add here users.ts. And in users.ts, what I'm going to do is I'm going to also import Hapi here. And I'll try to make this even bigger in case there's problems. And I'm going to define the plugin, users plugin, type hapi.plugin undefined. And that's an object. And this object has a name. And for the name, I think we're just going to use I like to prefix it with app, generally for like the business logic specific ones, but really any name could be used here. And let's see, what's this about? Oh yeah, it's, let's already export that. Users plugin. Okay. And now we need to define a register function as we did before, and this register function will have an async function which gets the server passed to it, and here we could already start by defining some roots. But before we do that, let's talk about another thing. So we're going to import this into our server. And I'll open up server. So I can already import it here. Users plugin from plugins users. And we're going to register it. That's all good. And if we go to users, we have a a challenge here, because essentially we could already start defining different routes here, with method as we did here, and handler and path, users. You know what, we're going to probably start with this post in order to create. So the method here will be post, the path will be just simply users. I can make this full screen. Great. So we have this method and path, and then we obviously need a handler. And the handler can either be here, we can either write it inline, or we can just give it a name and then define that below. So create user handler. And here we're going to define a function called an async function. Async function. Let's see. Create user handler. And that accepts a request, which is a Hapi request. And this helper, which is like the Hapi. I think it's called the response. Hapi.response toolkit. Is that the one? Yeah. Great. And if you remember from before, we could access this server object .app. And we have Prisma. So how do we have Prisma here? Well, how is this even typed, right? And if you're joining a bit later, I will show you. We did that in the Prisma plugin. We use this technique, this TypeScript technique called module augmentation, in order to add the type for Prisma. And so that's why in our users plugin, we actually can click on that, or go to definition, and it goes here. So that's all wonderful. But we have a problem, right? We define these 3 plugins in our server, and the order that they're registered doesn't matter. And what we want to ensure is that when the users plugin loads, we want to make sure that Prisma is already being loaded for us. And so for that, we can use this feature that plugins have, which really, this is, I think, one of the killer features of plugins, is that we have these dependencies. So in these dependencies, we can pass here an array. And what I'm going to do is I'm going to open up here the Prisma plugin. And as you remember the name, you might remember the name was Prisma. So here I can tell it, hey, this is one of its dependencies. I really need you to load Prisma before you start loading this plugin. And so under the hood, Hapi will look at these dependencies and then figure out the correct order for loading all of the different plugins. And so now we can be sure that this Prisma Client instance is accessible within our handler. Okay, I forgot a comma here, and that's why I'm getting the squiggly line. And so, all right, now we can already start playing with this handler. So we have a post handler, and request, in order to access the request payload, we can access it through this. So what we're going to do is we're going to use this in order to create a user. So might remember, in order to create a user, we're going to use this Prisma instance, and I'm going to actually destroy that so I don't have to type the whole thing along the way. Okay, so we have Prisma here, and then what we're going to do is we're going to do Prisma, and then here we have the different models. In this case, we want to create a user, so we're going to use the create. And here we're going to pass it this data object. And then in this data object, essentially, we can pass all of these different fields. So email might be dot payload. So we can go payload dot, well, first of all, it's worth pointing out here that there is no way for the TypeScript compiler to know what will be the type of payload. And the reason is that payload is a runtime object that will come in from the caller to the API. And so there is no way for TypeScript to know its type. And so there is a strategy that can help us deal with this, and that's called a type assertion. So a type assertion is the main mechanism that TypeScript provides in order to override variable's inferred type. So if I sort of hover over this, I assume that it will just be, there we go. It could be just one of these, which are either a string object, an internal readable, or a buffer. And these are the types that are generally accepted by Hapi in terms of user input. But we want to verify that it adheres to a certain structure. And we'll look at that in a second. But first, let us take the email from the payload, and then we'll also take first name, last name, and I think we also had social. Right, yeah. So payload.social, or we could even do it this way, just to be explicit about what we're persisting. But you know what? We'll leave it as that for now. And okay, now let's address these type errors that we're getting here. I'm going to close this because we no longer need this side. And in order for us to do a type assertion, we need to define a type. So I'm going to define here a type using an interface. And this interface should represent what we expect to come in. So I'll call it just user input. And here we expect a first name to be of type string, a last name, an email, and then we also have this social object. Just for reference, I'm going to open up the schema here, Prisma schema. So if you remember, we had this JSON field, a quick refresher on what a JSON field is. So a JSON field is just a free-form JSON field that you can use. This maps actually to the JSON B type in Postgres, and I can double check that here by opening up the CLI. Yeah, exactly. So we have this JSON B field. And the great thing about these JSON fields is that there's some data that we don't really care so much if it adheres to a specific schema. So for example, email and first name and last name, these are all part of the database schema. And so they sort of, you can't just change their type randomly. But with social, we can pass in an object. And for example, we're going to maybe pass in, I think in the seed script, we had Facebook and Twitter, and imagine that TikTok suddenly takes off and we want to add it. We can just add that, and that will not require any change to the database schema. So if it's important data, generally the rule of thumb is if it's really important data that you care about, that you want to make sure is also consistent for every row in the table, you probably wouldn't store it in a JSON field. But for things like social information that can be sort of dynamic and they can differ from one row to another, you can stick to a JSON B field. And so social is obviously not, it's not a native data type, I believe it's called, but rather it's an object. So I'm going to open up an object here, and I'm just going to make this question mark makes this field optional. And maybe we'll have Twitter and GitHub and website and maybe TikTok too, because why not? Let's have fun. All right, I'm going to pause here, see if there's any questions. We've got 18 viewers live, so thank you for everyone who's already joined. And yeah, if you've joined late, you can rewatch this. This will also be available later, so you can rewatch it from the beginning. And there will also be an article that will accompany this. So if you're more of a reader, you can sort of follow that at your own pace. So coming back to the code, we define this type here, and what we're going to do is we're going to use this technique called type assertion, so that the compiler is relaxed about and it knows that, hey, the type that we're providing it is correct. So the way that you do a type assertion is using this as syntax. And you can see that as soon as I added that, the squiggly lines went away. Now, it's worth pointing out that this is just to appease the TypeScript compiler. This will not actually do any runtime validation. In the resulting JavaScript code, there won't be any of this. This is just to make sure that the compiler knows, that we tell the compiler, hey, we know what's going on here, you can relax. So this doesn't address validation, and so we really care about and because we really care about validation, we're going to handle that next. But let's give this API endpoint that we just created a go. So just to recap everything that we did here, we created this users plugin. We looked at dependencies. We defined a dependency on Prisma, and that's this Prisma refers to the name that we gave the Prisma plugin. We defined here a new route, a post route that has a path users, and we've defined a handler, and in this handler, we're accessing Prisma, and we're doing this type assertion, and we're making this Prisma user create. Now, I forgot to add here an await, and if I'm already going to add await, I should probably add a try catch block. It's always important to handle your errors. And so, assuming that this succeeds, if it didn't throw, we would probably use age.response. And we might want to take the user ID that we created so that we can return that to the user. So I'm going to persist the result of this create call in created user. And it's now almost 7, so we're about an hour in. I think we'll go for about another half hour. And hopefully in this next half hour, we'll look at validation, some of the other endpoints for users, and some of the testing functionality. So we have this created user. We don't even need to define a type for it. It will automatically infer it because Prisma is generated for us in TypeScript. Excuse me. Okay. So we take this created user, and we've got this nice auto completion here. So we're just going to pass in. We're just going to respond with a object containing the ID of the created user, and we can do, I think 201 is the HTTP code for when you create an entity. I will double check that, but let's see. And (201). Indeed, 201 is the status code for created. Great. And so I'm not going to do any like advanced error handling. You probably addressed that at some point. But for now, what I'm going to do is I'm just going to console log the error for our debugging purposes. And also, it's also important to return. Essentially, a handler function should return either an object or it should return a promise. So in this case, this will return a promise, but obviously here we could include the error, but that might expose some information that we don't necessarily want to expose. So I'm just going to add a 500. Now, it's a bit cumbersome to keep track of all of these codes sometimes, and that's where Hapi boom comes in. So let's see what we can import from Hapi boom. There we go. So we have all of these really nice errors here, and is that the name though? Let's double check that. Happy boom. Let's see. API. Oh, right, yeah, we can just import boom as an object and then access it via that. So here we can just go boom dot bad implementation. Is an object necessary here? Oh, right. Yep. I think that just needs to be passed into response. We can double check that. In fact, the quickest way to double check that would be to do this in the status endpoint. I'm just going to quickly use that as a test for. So instead of replying with this up, I'm going to reply here with boom.bad implementation. Let's see if it's smart enough to know how to import it. No, it isn't. And let's see if that works. I'm not 100% sure about this. And we could do that here simply with a simple HTTP request. I'm going to make this a bit bigger so we can all see it. Hope the size is okay by now. And I'm going to make a call. Oh yeah, I think the server isn't running. Which is, let's see. Okay, it's running. And now I can make this HTTP call. Okay, that didn't work. Let's see if in the documentation we have something on how to. Let's see. I think we can just return this and then Hapi figures that out. So let's try this. Okay, that didn't work. Maybe it needs to be a function. Oh, there we go. Okay. I wonder if that returns also the. It isn't, and that's probably due to. So there we go. That will be used in the logs. But so one of the focuses of the reason that we're not actually seeing this in the HTTP response, which we made here. So when I made this call, we just got this sort of generic error. And the reason for this is that Hapi was built with security in mind. And so a lot of the defaults of the framework are built sort of this idea of security in mind. And that sort of plays out here because it doesn't automatically expose any errors which you might be interested in as sort of the developer of the backend, but not necessarily exposing that to the user. And so I think there is another property that we can pass here, can't remember it right now. Let me just sort of look up the reference for that. But there is a way to give it the fail action. But we'll look at that later. Now we just know that we can use this boom functionality in order to have a nicer we can pass this message. This will be logged for us. Okay. Let's give this a test ride. So I've got Postman set up here. If you're not familiar with Postman, it's just you can look at it as a REST client or a general API client. I think it supports different APIs by now, like GraphQL and gRPC. I think it does too. And I'm just going to try to make a post request to this /users endpoint. And when I do that, oh, I got in the response, I got this ID 28, and the status code was 201, so that's all good. And if I go to the database, I'll just open up PG-CLI, which is the CLI that I'm using, and I'm just going to select everything from user, and as we see, indeed 28, so I can select is equal to 28. I think it's just a number, and we can make that nice. Great, so that is the object that we created. That's all great. If I try to make call again, we should probably get some kind of like a unique constraint error. And that is because we have, if we look at the Prisma schema again, we have this unique. So if we try to send, to create another user with the same email, it'll fail. And then we get, indeed, we get this 500. And let's see what's the error that is logged here. So this is already diving into how. So there we go, we get this error. This error is coming from Prisma, and it tells us, hey, the unique constraint failed on the field's email. And then really we just, this is the message that we created in this row. So in here you could imagine that we could do something along the lines of like making sure if type of error, or if error instance of, and then the type here, whatever the type of the error is, and sort of we could do more fine-grained error handling. But we'll look at that a bit later, or perhaps in a follow-up stream. So, okay, so we created this user. We just saw that the unique constraint successfully passed. But what about validation? So if I go back to Postman here, what if I don't pass the first name? And I'm just going to make the email unique. You see, we'll get an internal server error, but the user won't know. So if the user sees this, if the API consumer, which could be a user, it could be another developer developing the front end, if they see a 500, they don't know what is the reason for why this failed. And so this is where validation comes in handy. In fact, if we should probably look at the error that we had here, and it's probably telling us error creating user. Yep, so here we have it. It was missing the first name, I think it was, that I removed. Exactly, the first name was missing. So how can we prevent this so that most of the database calls that we end up making already have gone through the validation? Well, Hapi comes with this library called Joy, and we're going to import that. Excuse me. And before we get into this, I'm going to pause here and just see if there's any interesting comments. Okay, so Fraser Jeffrey has mentioned that VS Code has extensions which allow you to use HTTP instead of standalone client like Postman. So thank you for that. Yeah, I think also Nico shared with me recently another nice tool. And Mark Bennett, so you're asking if the questions go here. Yes, it's best to ask the questions here. Okay, increase the browser font size. Let me see. Where did I have the browser open? Okay, well, I'll be sure to do that whenever I open up the browser next. Don't think we need any of this now. How are you able to use HTTP command in the terminal? Well, good question. So HTTP is simply a CLI called HTTP. Oh, really long. But HTTP, you can go to that. I'll share the link. It's just a CLI tool, and it's almost like curl, but it has some nice a nicer interface to work with, and I think it automatically parses the JSON and like makes it prettifies the JSON. So that was that. Okay, hello Patrick, welcome. Hello Alfie. And if there's no more questions, we will continue. So thank you for all the questions, and thanks for recommending Insomnia Core. I'll check that out, exception 360. Okay, let's continue. We have about 20 minutes left, and in those 20 minutes, what I'd like to cover is validation and testing. So, validation. Let's see. So, when we define a route, we have another property here called the options property, which is optional. And here we can pass all sorts of different things, but what we care about is the validate. So let's see if we can find that validate, and that's another object. And there's different things that we could validate here. If I just open up the auto completion I have, I can validate the parameters. The parameters are URL parameters, which we'll look at in a second when we implement the other routes. And then we have payload. So in this case, we care about payload. And what we're going to do is we're going to pass this payload an object, and that object will be a joy object. So this is what it will look like. So it's joy.object. And essentially what I'm going to be doing here is I'm going to be defining the structure that I expect it to be. So again, it's a bit cumbersome, but these validator objects are actually reusable. So we can actually move that out and then reuse that in other endpoints that accept the same payload. There are different strategies when it comes to defining these validator objects, but Joy does a really nice way of sort of exposing a declarative kind of like chain API. So here I can tell it that, hey, it's a string, and I can tell it that, hey, it's required. And the same thing I want to do for last name. And same thing for email, but it's not a string. It's not a simple string, it's an email. And social is an object that has maybe Facebook, and it's optional. And then we'll add Twitter, GitHub, and website. And I think at one point we added TikTok. Let's do that. Hope that's the correct spelling. If not, that's probably an indication of how old I am. All right, so we have all of these, and I believe website is not just a simple string, it's an URL. I wonder if Joy has a rule for URI. Okay, there we go, URI. Exactly. That's the right one, I believe. I can double check that. I believe that's the correct RFC. Yeah. Okay, wonderful. So we had all of these. We added all of these validate options, and now I'm going to try to make that same call that I did before using Postman. That was missing the first name, and let's see what kind of error that we get now. Oh, okay, so this is already better. We get a 400, and if you might remember that the 400 range of status codes in the HTTP standard refers to errors that are related to the requester's input or to the request. So this is already nice, but what if we wanted to get really specific with our responses? Well, we have a way to do that, and that is with the fail action. So we're still within this object, right? And now we're in this validate, and here we can pass it a fail action function, which has the request h and an error. So this is the error object that will represent the validation error. So when Joy fails to validate the request, we will get access to the request and to the response helper kit, and we can do different things here. But the simplest way is to just throw this error, and what we'll see is that when we throw it, we actually get a much more specific error. So that was validation, and now we have this nice messages, so we can add first name and ta-da, 201, and this is the ID of the user. All right, so great, we have this create user endpoint. Why don't we clean this up a little bit and move this object into user input validator. Move that below. Input validator. That's all great. And now let's define another route. So this route will be the get user, so that we can see what users we've created. And we're going to touch on a new feature that we haven't covered so far called parameters. So parameters can be defined as I'm doing now. And handler, get user handler. And options, we'll already add some of the validation logic here. So here we're validating the parameter, and although it's not an object per se, it needs to be sort of encapsulated within an object. This is an implementation specific detail. Oh, what are we getting here? Expected comma. Oh right, yeah, missing a comma here. This hasn't been defined yet. Function get user handler, and just to save time, I'm just going to copy that from here and close that, and ta-da, we've got a get user handler here, and we can already pass it Prisma. Obviously we're not going to have a payload, but what we're going to have is we're going to have the request params, so equals request.params user ID, I believe it is, and that's a string, so we're going to have to parse that into an integer, but we will get to that in a second. Okay, so we've defined here these params, and then in these params we have a user ID, and that is of type of joy.string, and we can even give it a pattern, and this will be a regex pattern where we use the digits 0 to 9, and can be multiple of those, and that's it. It ends with that. So it's essentially a string that consists of numbers. Oh, I forgot to add this tilde to make sure that it starts with that. And that was that. Now we have about 10 minutes left. Let's see what we can get in those 10 minutes. Okay, I'm glad to hear that Chmod777 is really liking this. And Ayush is asking, does Hapi also provide a way to handle authentication role-based authorization? And yes, it does, and we will also cover this in the next episodes. So stay tuned, there'll be more. Now, let's go back to what we were doing. Okay. So we had this get endpoint, and let's try to implement it quickly. So what stack is it? Okay, so Danilo Barros asked a question. Can anyone tell me what stack is he using? We're using Postgres, Prisma, Hapi.js, TypeScript. These are the main things that we're using. And also there's an article associated, so you can read that and get more background. Thank you for joining though. Okay. Now we want to use Prisma dot await user dot find one where, and then here I'm going to pass it an ID field, and that should be the user ID, but the user ID is of type string, and we're getting an error because it's expecting a type number, so we're going to parse this as an integer. And I always like to add the radix. Okay, so we have that, and now we want to return it. So we go age.response user.code 200. I believe the code isn't, it will default to 200. Let's see. Okay, great. So this user, it could either be user or null if it's not found. And so what we can do here is if no user, then we want to return an empty code 404, or we can use return boom, what was it? Boom dot not found. User can't. And then otherwise, return user, or best to do that with the response. So user.code 200, and there we have it. Let's give this a go with Postman. And so we created this ID 30. Let's try and get it. So here /users, and then I'm going to pass it the thing. Sending request. Okay, it looks like the server might not be running. Okay, I'm just going to, sometimes when the TS node dev doesn't pick up on the types when it keeps on reloading. But let's see, once it's running, now we can run this. Oh, and there we go. We got the full user object here with the response to. Okay, now let's try a non-existent, like a non-existent user ID. User not found. So indeed we got the 404 as we expected it to. Now let's try to pass in an invalid parameter, because you remember we set a validation. Oh, you see we got the 400 invalid request parameter input, and we can use this fail action here to get a more specific error. So instead of just getting this, we'll actually see why. There we go. So user ID doesn't, with the value AAA, fails to match the regex pattern. Be aware that if you are using this, if you are rethrowing the validation error, that you might expose some details, like in this case, we're exposing the details of what the regex is, but in terms of security, this should still be fine. Okay. So now we did that. Now let's look a bit at testing. So far we've tested the logic of these. We're just going to make this a little bit slower, but not changing any of the code. So we had this post user and get user handler. Before we go on to do the other endpoints, let's look at how we could do testing. So I've set up Jest here, and I'm using this plugin with TS Jest in order to be able to run it with TypeScript, so that the tests are written in TypeScript. And I've sort of created a skeleton here for what the tests could look like. I'm just going to give this as an example. So here I created just a test for Prisma, and in it I just instantiate the Prisma client, connect, disconnect before and then after, and then I just do a test query, and then I expect the data to be truthy, and I can run this in the terminal. I will make this bigger again. I'm sorry if it was not legible. And so I could run this test here by npm run test. And there we go. It's a bit slow. Okay, so we got some errors here. And that passed. So which one failed? It failed the user's test. Why did it fail? Error cannot find create server. Okay, yeah, that was... Let me just don't save. So let's open up that user's test. So let's look at the status test, because that's a really nice, simple endpoint. So what we need is we need to be able, in order to test a Hapi HTTP server, we need access to the server. And we need access to the server before it's started. So I'm going to refactor this a bit so that it matches our use case, and so that we can just import this server object before we start it. And so what I'm going to do is I'm going to break this start function into two separate functions. And these two separate functions, one of them will be called create server and one of them will be called start server. So create server will essentially register the plugins and call await server.initialize. Initialize will initialize all of these plugins, but not actually open up the server for connections. And you'll see in a second why that's relevant, and we need to return the server. And then here in this start, you know what we can do? We can just take, we'll rename it start server. And we can, instead of using the global, we can actually pass it in. So the server will be happy.server, and then await server.start, and then return server. Great. Now we will remove this, and instead of this being the main entry point for the application, I'm going to create a new file. Oh, whoops. Okay, so I'm going to create this new index.ts file and save that in here. No, I don't want it to be markdown. Okay, so we have this index.ts, and I will also update package JSON here to start index.ts, and then import create server start server from server. And then what we're going to do is we're going to create server. Not sure how that happened. Yes, create server, and then we're going to start server. We can just pass it the function because it will resolve with this happy server, which we return here, and then it will get passed in here. So, and then catch error .log error. Okay, so that's our entry point to the application, and I'm gonna just make sure that it works. So npm run dev, that should hopefully start the server. Okay, and that worked well. Great. So what can we do now that we have this create server function that already initializes all of that? Well, in our tests, we can, before all, tell server import create server from source/server, and we can assign it the value, but it's async, so we need to await. And then here we have server. That's all nice. Now, let's see, do we need to do any cleanup? I believe we need to call the server stop. So here we create And then after all the tests run, we can await server.stop. And stop, yeah, it will stop accepting the connections. And a quick reminder that we had in the Prisma plugin on post stop. So this will actually disconnect Prisma after that. And so we don't really care about Prisma in this test, but that's just a good thing to know in terms of some of the Hapi specific details. So now we have this test, and what we're going to do is, this is where the real magic happens. So there's this inject function which allows you to inject a request into the server that we created, even though it's not actually listening to any ports. And what that allows us to do is it allows us to do integration testing. So in this case, what we're testing is how is the HTTP layer working. We're not actually doing unit tests for the specific handlers, but we're testing really the application from the perspective of the HTTP API that it exposes. And that's why it's an integration test, because it actually integrates a lot of different things. It integrates Hapi, potentially Prisma, not in this test, but it tests the plugin, and it tests the handlers. And what we could do is we could actually also test validation rules. And so that would prevent us from having to every time use Postman in order to test requests to the API. And so here I'm going to inject, and when you inject, you can pass it a URL. In this case, we're testing the status endpoint, which has the simple, it's in the root, and we can tell it the method. Now, if I do post, because post isn't defined, I expect to get, so wait, first of all, const response equals await server.inject, and now we have this response object. This response object allows us to now look at what came as a result of this API request, this simulated request. Response dot, so we have the status code, and then we expect that to equal 404. In fact, I can tell it call, either escape that or just use a backtick instead. Okay. And so this test should pass. And let's run that. I can actually pass the watch here, which will get passed down, and we'll keep. Oh, let's see what failed. That was in users test. Let's see it. Users test. Right. So that failed. Let's just remove that and try to run that again. Thought I had a way to watch tests. Let's see. We run npx jest watch. There we go. Now it's in watch mode, which is nice because I can just, in a single button, I can rerun the tests. And it's much quicker because I think it doesn't, it sort of tracks, it sort of keeps a cache of the tests transpiled. Great. So now this is really like test-driven development. We're a bit over time, but I'm just going to continue to cover some more of the tests. So here I'm going to introduce here a get status endpoint works, change that to get, and then we expect that to be 200. In fact, we could try to parse the response. .payload. and then what we would expect payload dot up to equal true. Let's see if that works. Great, that worked. Now let's look a bit at the tests that we might want to introduce here. So I'm going to, similar to how we did that with the status, I'm going to import this create server function. And here we create the server, we stop it, and now we want to actually send a request in order to inject a request in order to test the creation of a user. And so here we can do const response equals await server.inject, and then we pass it an object method is post URL is /users. If this is any easier, I will open up here the users plugin. So we're going to test essentially this endpoint that we can successfully create, and we want to pass it some payload. So I'm just going to copy some payload that I have some prepared ahead, and that will be our payload. So first name, and let's see. Okay, now we can expect response.status code to equal 201. And what we could also do is we could try to parse the response payload which contains the ID. And this is why I'm using actually this user ID here. I'm setting it here so that I can use it in other tests. And so here what I'm going to do is I'm going to set user ID is equal to JSON.parse response.payload, and then if that's this .id. If you remember, that was what we returned here. Yep, so it was this ID. And expect user ID to be truthy. I think that should be enough. Now let's see how our test's doing. Okay. In fact, we could filter with this P pattern users. And did that work? Okay. Well, okay. Maybe another time we'll figure that out. Filtering for watching. Okay, so that test passed. Now, what if we pass invalid input? So, with invalid input, so here say we remove the first name and last name, and then we expect it to be, I think, 400 or 400, I believe it's 400, invalid. And let's see if that test passes. There we go. So that was testing. And what I've done in the Git repositories, I've integrated all of this with GitHub Actions. So this is the GitHub workflow file. And the nice thing about GitHub Actions is that now you can actually start these service containers. So in this case, we're actually starting a Postgres container. We're telling it, hey, we want this username, we want this password. And then what we do is we are running the migration here, and we're running the tests. So if you look at the repository on GitHub, you will see actually that this will run the tests. So first it'll run the migrations so that the database is created with the schema based on the Prisma schema. And then it will run these tests, which is really nice because these are integration tests and they will run on every commit. So with that in mind, let's look again at our list of endpoints. And maybe we'll wrap up with the delete endpoint, which is a fairly lean one. And let's do that TDD style. So for that, I'm going to first just write the test. And I'm going to do that simply by just copying this and modifying the inject. You know what? So delete user. And for that, we're going to use the method delete. And here I'm going to actually use this user ID that we created. So here we create a user and we assign that user ID to this variable. So we're going to interpolate that into the URL using these template literals. There's no payload necessary. Great. And then I believe 204 is the code that is used when deleting. I'll also be sharing some links to some resources on REST if you're interested. This is from the Stack Overflow blog. Let's see if we have any questions before I run along on this. Okay. So we have another question. Do you recommend Hapi for a GraphQL API, or would Nexus be the right choice? And do you have plans to do streams about GraphQL with Prisma and maybe together with Nexus? So I haven't actually used Hapi with GraphQL, so I can't comment on that. Nexus is really great, and of course there's many other options out there. And as for plans to do streams about GraphQL with Prisma, I'm sure that we'll have more of those. I can't promise anything concretely right now, but I'm sure we'll have a lot more live streams. Recently we had Ryan Chenke join our team, and he's very, very experienced also with GraphQL, and so we'll hopefully also get a look at that. And so coming back to this, let's see. So we wanted to do the implementation for this delete user, and that will be in the users plugin. And so it'll look very similar to the get user. So I'll just copy that and I'll make that bigger. And so here the method will be delete and handler, and we'll validate in the params, and then we just need to define this delete user handler. I'll do that here. In fact, I will copy this function and base it on that, rename it, and then here we have the user ID, Prisma, and then here we want to delete where ID is user ID, and let's see. I believe 204 is empty, which is what we want to do in the case of. So I don't think it can. So user in this case is always a user, otherwise it throws an exception if it fails. So let's wrap this in a try catch. We don't even need the response, and then here we can just go return age.response.code 204, and in this case we return boom dot bad implementation, fail to delete user, And now I just ran prettier, so it's nice and pretty. And let's see how the tests are doing. It's kind of a shame, you know what? Because the whole point was to show the test-driven development approach. So I'm just going to make this empty. And let's see. It should fail now. There we go. Great. So it failed. And if we re-enable this, then the test should pass. So indeed, we wrote the test before we wrote the implementation, and that's kind of like the idea behind test-driven development. So with that, I'm going to wrap up the stream. But before I do, I'm going to take some questions in case there's any. Thank you for the thank you, Hood Watcher. I'm glad that you enjoyed this. And if there's no more questions, we'll wrap up on that note. And there will be a follow-up article and also updated code with more of the endpoints implemented. All right, well, on that note, I thank you all for joining us today. It's really lovely. I hope you learned something. Couple of notes. So to summarize what we did in this stream, we implemented an HTTP server. We looked at TypeScript and using external types with Hapi.js. We looked at Hapi.js plugins. We looked at how you can use them to define dependencies. We looked at how Hapi enables testing and how Hapi integrates with Prisma. We look at how to define routes, at how to validate payload and parameters with Joy. And we looked at some of the TypeScript specific details, I think like type assertions to appease the compiler, and also the module augmentation when you're sort of overriding types defined by an external package. And we also looked at a lot of these Prisma CRUD operations. In the previous stream, we looked at mostly create and aggregate operations. And in this one, we did a bit of delete. We did, well, find, then we did create. And of course, there's a lot more that you can do with the Prisma Client API. If you haven't already, check out the Prisma documentation. And then before we leave, I just ask you to click the subscribe button if you haven't already. So thank you for joining us, and have a nice afternoon, morning, day, depending on where you're joining from.